All right, I think we're live. So welcome everybody to this second webinar in the series of containerization. I'm still Chris Peters of Data Minded, and I still have with me the one and only Pierre. Pierre, can you also say hi to the audience for a bit?
Hi everyone, thanks for joining us today. I'm a data engineer at Data Minded.
Yeah, cool. All right, so as usual, we're going to dive straight in. We only have 30 minutes, so we're going to keep it very focused. After the end of the 30 minutes, if you want to hang around for questions, that's okay, right? So, but let's dive straight in. This is the second part of the webinar, where in the first part, and the slides are coming up, the first part we looked into moving your notebooks to containers. And now that you have a container running on your machine, we want to run that container wherever we want, right? So maybe Pierre, you can go to the next slide. Yeah, indeed. So that's the second part. After this part, there will also be a third webinar where we look into how we orchestrate all these containers at scale. So today is just focusing on deploying the container somewhere. There will still be a hackathon after all of this. It will probably not be in our office in Leuven, unfortunately, because of Corona. We'll probably do it virtual, but it should be as fun. And if you want to follow along on the webinars, you can also go to the website dataminded.be/webinars, where you can rewatch the previous ones and enroll in the next ones. All right, so why are we doing this, right? So I gave the analogy in the beginning that shipping containers are actually really cool because they can ship any kind of good from A to B, as long as it fits in a shipping container, right? So it can be cars, it can be bananas, it can be presents, it can be computers. Whenever you can fit it in a shipping container, you can move it from A to B. And the same principle applies actually in software in general, is that there's this notion of containers where as long as you can package your workload in a container, it can be Spark, it can be Python, it can be Elasticsearch, it can be a MySQL server. Whenever you can package it in a container, there is plenty of options available for you to ship it, not just to your own machine, but to all kinds of services in the cloud, wherever you want. So you can ship it to Amazon, to Azure, to Google, to on-premise workloads to your machine. And today we're going to look at particular kind of workloads because containers are used everywhere in IT. We're going to look at data workloads, right? So we're going to continue on the example we gave earlier of the containerization of the notebook. If you want to follow along in the handouts, you can download the slides that Pierre has made. So you can download them in the handouts, or you can just follow along with Pierre. With that, Pierre, I leave the floor to you. Wish you all the best.
Thanks, Chris. So I'm going to start with a quick recap from part one, because maybe not everyone was able to see it. So what we did in the first part, because we needed a use case to demonstrate how to go from a notebook to production in a container, we took a simple Titanic use case and we Dockerized it. So we started here on the right from a notebook, and I won't get into the details. You can rewatch the webinar, the first part if you want. But in a nutshell, it was doing something very simple, which is looking at a list of passengers, looking at some characteristics of theirs, and determine if they are likely to survive or not based on a prediction. And so what we did in the first part is start from the notebook, extract that to some well-organized code and tests. We wrote a Docker file to define our container, so that produced a Docker image. And then finally, we ended the first part running that container on our local machine. And to go there, like a bit more concretely, we took a few steps. We made sure we didn't put any secrets in the code. We versioned the code. We pinpointed the dependencies. We organized the code. We wrote unit tests. And we declared the whole thing in a Docker file, which ended up in a portable image that we can run locally as a container. And so here you have a GitHub repository where you can find the code for everything we do in those webinars, and you will find the part one code specifically in the part one folder there. So this is a more visual explanation of what we did, but I won't go in details. But again, those are the steps that we took to put our notebook in a container, basically. We ended with a Docker file, which, if you remember, is a file where we explain how to ship everything in a container. So we started from a Python image. We added some secrets. We installed our dependencies, and then we installed our code, and we explained how to run our code. So that's the file we built. And with that, we run two commands at the end of last time. The first one is to actually build the image. So we run a Docker build of our Docker file, and that produced a Docker image. And we gave it the name Titanic Survival Prediction V1. And this produced our image. And then the final step was to actually run it on our machine. And for that, we use a Docker run, which took the image and ran it as a container. And we passed it some parameters to actually point to our S3 bucket and to the path to the data. And this actually executed on our machine, and we could see, yes, it's loading data, it's doing some prediction and showing a sample of the prediction. So that's wrapping up everything we did in the first part. So what do we want to do today? Well, exactly the same thing, right? We still have the same notebook, the same code, the same Docker file, the same Docker image. We run it on our local computer, but now what we want to do today is to run the same Docker container in the cloud. So what we're going to look at today are, okay, first I need to explain a bit what are container runtimes. How do you actually run a container? And it's a vast ecosystem, so I'll give a brief overview of that. And then concretely, how do we run this in the cloud? We first have to look at the different options that we have to run in the cloud. And concretely, we're going to focus on one technology, which is AWS Fargate, to deploy our use case in a hands-on section. So let me quickly talk about container runtimes. This picture explains a bit the overall picture of how building, storing, and deploying containers works. On the left side, you have what we call the client. That's where we use commands like Docker build, Docker pull, Docker run. When you do that on your machine, the first thing that happens is that you need to store the image somewhere in a registry. So that's the right part here. And then finally, when we do a Docker run, this takes an image and makes it into a container that actually runs somewhere. And for that, you need a runtime. And so in the first webinar, everything was pretty simple because all of this happened on our machine because we used, in my case, I used Docker for Mac, which was installed on my machine. And so I could do everything. And you didn't see any of that because it felt like, yes, we're just building and running locally, and so everything is here. But when we want to go further and run this on the cloud, we can look at those three things separately, like how to build, how to store, and then how to run. A little detour to explain something that I already touched on in the first webinar is that Docker is only one implementation of something a bit, actually much bigger, which is this Open Container Initiative, which is an initiative to make the structure of containers completely standard so that we can build an ecosystem around it. And so this cartoon here depicts that, is that actually under Docker, really what you have is a standard container runtime, runc. And so what we will see in the next slide is that there are many, many, many more options than just Docker, which is interesting also, by the way, if you've read recently maybe that the Docker has decided to make some of their features paying for big enterprises. And so the thing is, you can still use that if you're a small enterprise or if you're willing to pay, but you also have plenty of other options. And so you remember we have several steps. We have build, we have store, and we have run. And those pictures here, I'm not going to go into details. It's just a few of the options that you have. You have many options to build, many options to store, and many options to run. So that's good news, right? We have a standard definition of what a container is, and we can choose our tools. Here you have
to add to that, Pierre, I think this is specifically relevant for people more in enterprise environments, because as Pierre mentioned, Docker now starts asking for a license to use Docker Desktop. And I think it's okay to use in startups or something, but whenever you become bigger than 250 people or something, you need to pay. So there's plenty of alternatives out there. And I think with the change that Docker now made, I think they will only grow, right? There will only be more alternatives out there. Right?
Indeed. And here I'll put a link to a more in-depth article demystifying containers runtimes, if you're interested. So with that in mind, now I just explained runtimes. I didn't touch on cloud yet. So now let's have a look at the landscape in the cloud. So each cloud provider is actually listing a few options to run your containers. So that's AWS. Here you have Azure. Here you have Google Cloud. And then even for what is called hybrid deployments, where you can do it in the cloud or on-premise, or you can manage yourself your deployment tools. you have plenty of options. So this can feel a bit intimidating. I won't even touch on Kubernetes, which is one of the big actors, because that's probably a topic for a completely separate webinar. What we're going to focus on today is Fargate. The only thing I want to say about all those options is that they're slightly different flavors of the same thing. They all want to help you to take your containers, store them somewhere in a registry, and then run them. But the flavor in which you want to run them depends on, do you want to manage the infrastructure? Don't you want to manage it? What is your cost expectation? What is the complexity of your use case, and so on. I picked AWS Fargate for today because it's, if not the simplest, one of the simplest way to deploy a container on AWS. Okay, so deploying our container on the AWS Fargate. So you remember that picture? We have 3 steps: building, hosting, and then storing, and then running. What we're going to do today is still use our laptop to build the image the same way we did last time, but then we need to store it somewhere. And that's going to be in AWS ECR, which is the container registry of Amazon. And then we're going to run it on Fargate, which belongs to the ECS, which is the container service of Amazon. So a quick word on what Fargate is. So Fargate, that's their picture from their marketing material. You just build your container image. You only need to define some memory and some compute resources to actually run this. You run your container, and then you only pay for what you used. And so behind that is the fact that you didn't have to manage any machines. You didn't have to spin up any instances yourself. You just declare, I want to run this container there with that amount of memory. And behind the scenes, in a serverless approach, AWS is running the container for you. And the next thing I need to tell you about Fargate, or ECS in general, is they have a few concepts. Unfortunately, it's not as direct as build your container and run it. You still need to define a few indirections in between your container and running it. So the first thing you need is a cluster here. So in ECS, we will have to define what a cluster is. And then we will need to define a task definition, and finally a container definition. So even though I told you this is the simplest way I found to run a container on Amazon, you still have a few steps to follow there. So just to recap, we're going to build the Docker image on our machine. We're going to publish it to the Amazon container registry. We're going to run it on Fargate. And then to see that it actually did something correct, we're going to look at the results in 2 parts. The first part is going to be look at the logs in CloudWatch, and then look at the result. If you remember, those will be the prediction for survival, and this will be as a CSV file in S3. So let's move to the hands-on section, and let's actually do this. I'm going to switch screen. So for the sake of time and simplicity here, what I did is already prepare everything, and I'm going to show you what it looks like. So I already opened all the windows I talked about. So the container registry, the container service, CloudWatch, and S3. And so if you remember, the first step we're going to do is build our container. So if you remember, this command is the same one we ran last time. So docker build I'm in the same project as last time. I'm just calling my image with a certain name, and then this is going to build my image. So it's following all the steps from the Docker file, and it's creating a local Docker file, your Docker image. Now, what I need to do is to publish that image. So I'm going to take the command for that. So first thing we need to do is give a tag, it's called, to our image. So what we're doing here is saying, hey, let's tag this image that we just built with a tag that corresponds to the Amazon registry. And then finally, what I need to do is to push that image to that registry. So those are 3 simple commands. So now when I do this, what's the outcome of this is that if I go to ECR here, you see I have a repository for this. If I refresh now, we can see that I've pushed my Docker image with the V1. We can see it's actually quite a big image. We could probably optimize this, but we won't do it today. And so that's it. So now we have a Docker image that we built on our machine, and we published, and it's available in this cloud. So now we would like to run it, right? So for that, we go to ECS. And the first thing you can see is that I've created a cluster called webinar containers here, and there's nothing running yet. So it's ready for us to run things. The second thing I told you we need to define is a task definition. task definition. And here you have one task that I called with the same name. And we won't look into the details, but basically it's where I define, what is the Docker image we want to run, what is the command that we want to run. It's a bit intimidating, but basically I'm saying, please run this image that we put on ECR and run it on ECS. So what I'm going to do now is here from this UI, say that I want to run the task. I'm going to say I want to run on the webinar containers cluster, and I just need to say in which network I want to run this, and that's it. So then I click Run Task. And this will take a bit of time. So you can see now in ECS, we have a new task. It's here, right? And we want to run this. And now you can see the state is provisioning, and it's going to take about 1 or 2 minutes because this is a serverless approach with Fargate. So as I said, I didn't have to manage machines, instances, but behind the scenes, Amazon is doing it for me. So it takes a bit of time to get there. So while it's doing that, I can also show you, I also created in CloudWatch, which is where we collect logs. I created what is called a log group. So here it's just a place ready to receive the logs of my running container. And then finally on S3, we have this bucket that we created with the input data, the training data and the testing data. And if everything goes well, we should see an output file here being created by the container. So let's go back to ECS and refresh. Now we can see that it's running, meaning if I go to the logs and I refresh, I should see that there's some logs, yes. And if I look at the logs, if you remember, those are the exact same logs that we've seen last time. Basically loading the training data, the testing data, extracting features, training a classifier, and then doing some prediction and showing a sample of the prediction. So that's all well and good. The task now is probably finished. So if I refresh, it won't be here anymore. And if I look in S3 and I refresh, we indeed have an output CSV file. And if I go and download this file, it's a CSV file with the output of our predictor. So it's the likelihood of all of those passengers to have survived given their characteristics. So that showed you how to take our container that we ran locally last time and run it on the cloud in Fargate. I want to go back to the slides for a minute. So those are just slides that we explain what I just did. So publish the container to ECR. We did that. Then we have a cluster, we have a task definition, and we just ran it. And then finally, we check that we have the logs in CloudWatch, and we checked that we have our output on S3. So this is all nice. Unfortunately, I kind of didn't tell the whole story because I prepared some things in advance for you, right? So if you think about this, there are quite a few pieces of infrastructure that are involved. So yes, we have our machine with Docker installed. We published to ECR. Well, I needed to create a repository, to host our image. I needed to create some policy to say, yes, I can publish images there. Then to use ECS, we needed to create a cluster, a task definition, and create some roles so that we can execute the Docker image and access the S3 bucket. And so indeed, we have also an S3 bucket that we needed to create, and we have a CloudWatch log group. So why am I showing this? Is just to say, before I could do the demo, actually I had to provision all this infrastructure. And one really good way to do that, that we do as much as we can, is to use what is called infrastructure as code. So back to this slide first, sorry for a second. So all of that can be done by going to the Amazon console and clicking around, creating your ECR repo, clicking, filling in the wizards, same thing for everything. But first, it's tedious, it's error prone, and also it's hard to maintain and to share with someone else, right? So what a tool like Terraform is looking to do is to do exactly what you can do with clicking, but you define everything as code. And we will see in a minute how that looks like. So basically, you describe how we want to build all the pieces, but with code. And when you run your Terraform, basically, it's going to create things as if you clicked in the console, but it's defined through code, meaning you can version your code, you can test it, you can check it in a Git repository, and so on. So I won't go, because this might be a bit intimidating. I don't want to go into the details, but if you remember that picture here, we have like 1, 2, 3, 4, 5, 6, 7 pieces of infrastructure we need to create before we can do what I did. And this is what it looks like in Terraform. You say, hey, I want to create an S3 bucket with that name, and I want to create a log rule with that name, and you pass parameters. And when you execute this, it's actually creating things for you. So the same thing is true for the ECR repository and so on. Again, I won't go into the details here, but this whole code is capturing everything that was needed to create the infrastructure for the demo today. And by the way, that's part of the GitHub repository I made available for you to look at. And finally, the same thing for ECS and IAM. So why am I saying all that? Basically, my message is I looked really hard for the simplest way to deploy a container on AWS. And it worked quite easily, and my demo was quite, short and to the point. But before I could do that, I had all those steps to do that I didn't show you, right? And so, to summarize, to deploy our Titanic survival predictor to Fargate, what did we do? We provisioned the AWS infrastructure. We built and published our Docker image to ECR. We ran our container on Fargate as an ECS task. And then we check the log in CloudWatch, and we check the predictor output in S3. So looking at all we had to do, I just wanted to talk briefly about Datafile. So if you were in the first webinar, Datafile was already mentioned. It's a tool that we built at DataMinded that deals exactly with this kind of topic. So how to be productive as a developer, to deploy my containers, orchestrate them, and so on. So to the point that we have today, I will give a short demo of what Datafile can do to do exactly what we just did, but with a single command. So let me switch again to my terminal. I'm going to clear my screen, and I'm going to prepare this. So here I'm in the same folder as before, and with a single command, which is Datafile run. And then, so I'm saying to Datafile, please run my project in an environment, which is basically behind the scenes running on Kubernetes. I just do one command as a developer. And what it will do is run my container. So build my container, deploy to ECR, create all the provisioning about infrastructure we just talked about, and then run the image and give me the logs immediately in my console here. So in a few seconds, we're going to see that. So now it's waiting to run it. And you see here, you recognize those logs to be the same as the ones we had both locally on our machine and also in Fargate. Well, Datafile run did exactly the same thing, running our code on AWS. So you see the logs here, but this actually ran on AWS. And so back to this slide. So I just did that, right? Run Datafile on a given environment. And yes, I forgot to show, but in the UI of Datafile, then you can go to your project and you can see the logs in a convenient way. So you don't have to juggle between going to CloudWatch and so on. Everything is centralized for your project. You can see the logs. So with a single command, Datafile does everything we did today: provisioning the ECR repo, build the Docker image, publish it, create some service accounts so we can have permission to access S3 and so on. It's actually running the container on a managed Kubernetes cluster. It's collecting the logs and metrics in a friendly UI, and it's showing you the live logs in the terminal. And that's a feature we love to use and our customers also love to use. And with that, I think I covered everything for today. So let's have a quick look at what's coming in the next part, because so far, what have we been doing? We have been taking a notebook, convert it to code and test, run it on our machine. And then today we showed how to run it in the cloud, but that's only one container, right? So in the next part, we'll do the following. We will take our example and split the program that is doing both the training, the cleaning, and the prediction in a single job. We're going to split that in many small pieces like we do in a typical data pipeline. And then we will see that, okay, but now we need to run all of those separate pieces and we need to orchestrate them. So we will look at what are the existing orchestrators for containers. And then finally, as a concrete hands-on section, we will use Amazon Managed Airflow to actually do that. So take our job that we run today, but split it in several pieces and orchestrate them. And that was it for me today. Thank you for watching.
For this quick and thorough demo. So yeah, indeed, maybe we were even 5 minutes before time, so that's really good. Maybe we can start with the Q&A already. So if you have questions, feel free to drop them on the chat on the right. There was one question from Jérôme already in the beginning, Pierre, when you explained like you had the different things, the different steps like build, store, and run. Do I understand correctly? Jérôme asks that Docker covers the 3 aspects, so build, store, and run, while the other alternatives can only do one of them?
Well, yes and no. So the thing is, when you run locally, actually you don't really need what we call the repository to store your image. This is just done locally. So yes, Docker on your machine can do everything. You can also install Docker on a remote machine in the cloud to be your runtime, but you still need a registry somewhere. So to some extent, yes, Docker can do everything. The other tools, you're right, typically focus on one of those things. For instance, ECR in Amazon that we use today only focuses on being a registry, and that's all it does. And ECS cannot store images, it needs a registry. And you can mix and match all those pieces together.
Yeah, and I think in practice, Pierre, correct me if I'm wrong, but what I at least see more often than not is Docker is being used for the build part, but then indeed your container registry is whatever container registry that your cloud offers. Like in Azure, you use the Azure Container Registry, and AWS the Elastic Container Registry. And then for running, I think it's actually a question to you, Pierre. Like there was Docker Swarm to run
Yes.
Docker containers, but is that completely dead, or is that what is the status of that thing? Because I don't see it often anymore.
I don't know exactly. I don't think it's used a lot these days. So in the early days, before Kubernetes, before all the cloud solutions for containers, what people would do is basically build their Docker image and then use one of 2 tools offered by Docker. One was Docker Compose, which is basically, now I have a lot of containers and I need to run them, and maybe they depend on each other, and I have some things to do in networking and mounting files and stuff like that. So that was Docker Compose. Docker Swarm was that, but on steroids, where you could actually, it's a bit closer to what Kubernetes is doing these days. So, but I don't think today Docker Swarm is still used a lot. Well, I don't really know, but I don't see it a lot.
No. So what we see in practice a lot is if you have small workloads like this, you can just schedule Fargate containers. That's the easiest. I think if you have more at scale workloads, I see companies moving to AWS Batch or Azure Batch or something similar, because then it's much easier to schedule a lot. And then if you really, next level, if you, especially with orchestration that comes in the next webinar, you see companies moving to Kubernetes as their standard platform. What is the advantage of having Kubernetes to run everything is that a lot of your software engineers already know it. So it is a familiar tool. It is almost the platform of platforms, if you will. What is the downside, of course, of Kubernetes? It comes with a lot of complexity. So we now, our default approach, if we go to smaller organizations with limited IT staff, we almost never do Kubernetes anymore unless they really, really want it. Then we look at more AWS Batch or something, but in bigger organizations, it still makes sense to adopt Kubernetes. And then, of course, and there's a few questions around that as well. With Datafile, for those who don't want to worry about whatsoever all of that anymore, they just want to build their Docker containers and throw it somewhere. That's where we build Datafile, right, to automate all of that end to end. So you have a lot of choices. That's the message, right? Once your code is in a container, you can go to any cloud, choose like any service you want, and like more and more providers also start offering support for containers. So it's almost a de facto standard, especially in normal IT workloads. It will be even more the standard in data workloads in the future, I think. Yeah.
Which also is nice because of avoiding vendor lock-in. So if you've been writing your code in a container, then you might go with one vendor, one cloud provider, but then you can switch to any other solution because your container is just standard. So.
Yeah, exactly. All right, so moving on to the next question of Chris. He says, is Datafile always using AWS in the back? So maybe I can answer that. Today, yes, we only support AWS, but we are actually building an Azure version as well. And we have the goal to also be on Google Cloud. So our end goal is to be cloud independent. But today, as our clients are in AWS, we are as well. But there's no reason why this shouldn't run on any cloud, right? And even like, I don't want to go there personally, but even on premise, there's no reason why this shouldn't run on premise, right? That's that's a whole other can of worms if you open there. Paul Arma asks, like, hey, is Datafile doing the infra as code, hence setup of ECR, Kubernetes, IAM, or is it running against pre-configured ECR, Kubernetes cluster, and so forth? Pierre, I don't know if you want to answer that. I can do it as well, but yeah.
So Datafile is doing the infra as code, actually. So we create all the resources and we do them. We have two notions in Datafile. One is project, right? You work on a project, and then you have the notion of an environment. And we provision things per environment. So an environment can run on one Kubernetes cluster. It can have, we will see next time, it can have a airflow, managed airflow for you. So we do use infra as code. But the whole point is that you don't have to worry about that as a user. So as a user, you only manipulate the notion of project and environment, and everything else is done for you.
Yeah, indeed. And maybe to add to that, we do support the notion of having multiple clusters, right? So if you have multiple AWS accounts or multiple networks, for some reason you want to run in multiple clusters, that is supported, right? So an environment can live in a cluster, and when you deploy to an environment, we know, like, okay, that's cluster A or cluster B, and we route that for you. Yeah. And then Taufik, hi Taufik, asks, thanks for the demo question. Will the process you just showed create an endpoint for API request using a container you push to ECR? Well, maybe I can do that question. So no, we did not create an API endpoint. So now there was just one big container that the data loading, the model training, the model scoring, and everything in one go, right? In the next webinar, we'll see how we'll decompose that and do it more step by step. I'm looking at Pierre, but I still don't think we would put an API there, but it would make sense that once you have a trained model to serve that inference through an API. So that's definitely possible to, yeah, indeed.
And that's a good point. If you look at the whole ecosystem of cloud for running cloud services for running containers, that's one of the differentiators, right? Like some services are better suited if you actually need interactive containers, typically a web application that you deploy or something like that. Then you need you need to worry about load balancing, you need to worry about scaling and all those things. So that's where exactly things like Fargate can compete with other things. And if you have a simple use case, maybe you just want a Lambda. So that's exactly the kind of differentiators for all those services.
Exactly, yeah. And it's pretty nice that indeed, again, you have your code in a container and then you can choose what makes most sense for you for that use case. Okay, then Brent asks, do Databricks users moving to running their workloads in containers on Kubernetes face performance issues due to non-optimized open source Spark engine? That's actually a very good question, Brent. And maybe Pierre, you want to add to that as well, but I definitely want to add to that as well. We've had clients moving a lot of their Databricks workloads to containers. The main reason being, if you look at Databricks, you pay for the compute cost, and then you pay like quite a hefty fee on top for the license cost. If you do that at scale, like more than 50% of your cloud invoice at some point goes to Databricks, and you're like, we need to optimize something here. And so they started putting stuff in containers, running those containers on AWS Batch or Kubernetes or Datafile or whatever you want to run it on. What we saw was two things. One is because if you do it at scale, you can use spot instances much better than if you do it in Databricks. I think Databricks now also supports it, but it's because you have per cluster, you have a use case per cluster typically, and it's much harder to use spot. While on Kubernetes, you can just use spot at a massive scale. So your infrastructure cost goes down tremendously. And also, because you don't have the license cost of Databricks anymore, that turns to zero, right? Now, there still are use cases where you might go like, hey, but this, even though like it is cheaper to run, it's faster on Databricks because it has some performance improvements, because indeed Databricks has their own runtime. And there are a recommendation as well. If that makes sense to keep on running that in Databricks, please do, right? So do whatever makes most sense, maybe in terms of latency requirements or cost requirements. Keep on running it in Databricks, but at least you have the option to move it to where you want it. And I think in reality, but yeah, that's anecdotal evidence, but I think 99%, if not 100% of workloads are cheaper and not that much slower on Kubernetes. So they don't run much, if at all, anything on Kubernetes anymore. I hope that makes sense, Brent. Pierre, I don't know if you've something to add.
No, you summarized it nicely.
All right, cool. I think with that, if there are no further questions, we'll all send you an invite for the third webinar where we're going to look at orchestrating all of this. We'll also make sure that you get a link to the code. I actually posted it in the chat already, so if you want to peek, you can download the slides in the handouts if you want. And well, I'd like to thank you all for this interactive webinar again. If you'd like to reach out for a demo of Datafile, of course, feel free to contact us, and then I'm happy to do so. All right, guys, take care.
Thank you. Bye.
Bye.